Hello, I'm Dr. Sarah Jane Potts from Specific, which is a part of the Materials Department at Swansea University. And today we are going to look at how we can both capture and store energy that comes from the sun and use it when we need it. There are lots of different solar cells and heaters. The most common solar cells are made from silicon. These are pretty expensive. So my work is on making low-cost printable solar cells like this one that can be made right here and work really well in our gloomy British weather. There are also solar thermal heaters, but these don't generate electricity, although they can be used to heat up your water. So together, they make your hot water and your electricity. These solar cells and heaters are used to power buildings like classrooms, offices, and even homes, providing sustainable energy that is both good for the planet and reduces your energy bills. They can even be used to bring power to rural places like these train shelters that would otherwise be without electronic displays and charging ports. But how does this work? When the sun strikes down and hits the solar cells, they change the solar energy into electrical energy through the photovoltaic effect. The photovoltaic effect involves a semiconductor system with a valence and conduction bands separated by a band gap. Photons are then excited between these electronic bands, creating a voltage difference between the two electrodes. If we look at how this works in a simple solar cell, there needs to be two materials with different electronic properties. One that is electron-rich, which will block the electrons, and one that lacks the electrons, which will block the holes. These are placed between two electrodes, which are the front and rear conductive contacts. When the light strikes the electrically different materials, photons are excited between the two electronic bands. This forms pairs of electrons and holes, while the materials in the solar cells block them from going in the other direction. And this results in electrical power being generated. The printed solar module shown here contains many solar cells which are side by side and is made up of multiple layers which are spray coated, printed and syringed in place. These layers include fluorine doped tin oxide, which is a transparent conductive layer, titania, which is a white pigment usually used in sun cream and even in your chicken nuggets, but here is used as an electron transport material. Zirconia, which is typically used in ceramics and dental implants, but here it's used to block the electrons, followed by conductive carbon, which include graphite as you usually find in your pencils. Here it is used as an electrode. Then finally, a perovskite solution is infiltrated through all of the layers, which is the light harvesting material. To make these, there are multiple steps we have to take. Firstly, the fluorine doped tin oxide coated glass is cleaned with a range of cleaning solutions and solvents. In our case, they are scrubbed by hand, which takes a little bit of a while and is about as fun as doing the washing up for your dishes. But we need this to make sure they are clean enough to make good quality printed solar cells. Next, the first layer of titania is put down using spray coating, with the glass heated on a hot bake below it. Then the following three layers are put down using screen printing. Screen printing involves a screen with a woven mesh and stencil, which allows the ink to be put down onto a range of substrates. The substrate being the printed onto, it can take the form of a variety of things from glass to t-shirts. As the ink is forced through the holes in the mesh, which aren't covered by the stencil, by the force of the squeegee, first the ink is scraped in on an even layer over the mesh with a steel coater. Then it is forced onto the surface with a polyurethane squeegee, leaving behind the print. Then the coatings are cured in an oven, and any parts of the print that need removing are taken off using scribing. Then the perovskite solution, which is the light harvesting material, the solar cells is made in a glove box and then heated up. Then this is syringed onto the printed layers and cured in an oven. Once dry, the electrical contacts are soldered onto the sides of the solar modules and the wires are attached. And here we have a finished printed solar module. These can be tested under an incredibly bright light, which is the equivalent of one sun, to see just how well they perform. And then we can encapsulate them and put them on our roofs. But what happens if the sun isn't shining, or the wind isn't blowing, or the waves aren't flowing? Do we go without? No. The answer is that we need to store this energy in batteries so we can use it when we want it. Batteries are found everywhere. They're used to power our phones, our laptops, along with many other electrical products at home, and even some cars and homes. Today, you're going to be learning not how to make the big ones that power our classrooms and offices, but how to make batteries from everyday items that you can find around the home. Batteries are able to store energy and then release it when needed by changing chemical energy into electrical energy. To make a battery, you will need two materials with very different potentials. Our copper coins will be our cathode, which is the positive electrode that will, when reduced, will be reducing during discharge. Then our zinc washers will be the anode, and this is the negative electrode, which will oxidize during discharge. When they are both put in an electrically conductive corrosive liquid known as electrolyte, this will allow a current to flow from the cathode to the anode when they are connected together. In our case, the electrolyte is the salt water, which will be soaked into kitchen towel between the zinc washer and the copper coin. So when we connect them together, the electrons will be able to flow from the zinc anode to the copper cathode, while the negative ions flow to the zinc anode and the positive ions, cations, flow to the copper cathode. This process is known as discharge. Some batteries are reusable, like the ones used in electric cars for storing energy in buildings. These are able to charge back up as well as this and reverse the process, but our penny battery is single use, so once the process has happened, it cannot be undone. To make a penny battery, you will need some copper coins, some zinc washers, a container of very salty salt water, so at least 1/3 salt water, some kitchen towel to soak up the salt water, a sheet of aluminium foil, and finally an LED or multimeter to prove it works. We will assemble them as cells with the copper coins forming the cathode at the bottom, the salt water soaked kitchen towel in the middle to form the electrolyte, separating these electrodes, and then the zinc washers to form the anode on top. So here I'm going to give you some examples of how to make it. I'm going to start with all of our stuff laid out before us. And I'm going to start by taking one of my kitchen towels and soak it in my very, very, very salty salt water. So you want them a nice circular shape so they aren't going to drip over the edges, which would be bad, which is why I'm scraping off any excess. So we place down our copper cathode and put the electrolyte on top like so, and we can cap it off with our zinc anode, and that is one cell, but we're going to need more than one cell in order to make our LEDs light up. So we're going to try and make 5. So once again, start with the copper cathode, then take our kitchen towel and soak it in the really salty salt water, and then try and remove all the drips from the edges and place it down. But don't do what I just did here, because that would be bad, as if you have it dripping over the edge, our battery will not be able to work. So try and keep it nice and dry at the edges and only have it damp in the middle between our anode and cathode pairs, like so. Let's do this again. So copper cathode, followed by our kitchen towel. Make sure it's really nice and salty, so dig it in there and wipe off any excess so it doesn't dribble, and place it down, and then cap it off with our zinc anode. Got a couple more times now. So once again, place down our coin, get as much salt in there for our electrolyte in order for the process to work. So the more salt we have, the better the process is going to happen. And then cap it off with our anode, and then one more to go. So one more coin, followed by one more bit of kitchen towel. Just soak that in really nicely. Scrape off the excess and place it down, ready to top it off with our final washer. And there we have 5 cells, which should hopefully light up an LED. So if you get one of these LEDs here and separate the legs apart, beware that the legs are slightly different lengths as well. So if it doesn't work the first time, switch it around to make sure it does. And then push onto both the kitchen foil and onto the washer at the top, and try and keep them all touching each other, and voila, you should be able to get your LED to light up. And so here you go. And that is an LED being lit up by nothing more than a bunch of coins and washers. So here are some examples that people have made before, just to prove that anyone can do it. So I hope you have fun making your own coins, coin batteries, and thank you very much for watching, and I hope you enjoyed it.